Welcome to the AI for You Cafe. Today we have the speaker Joachim Moret. He is from Barcelona and works in the Oficina Técnica de Gestión for the Plan Nacional de Impulso a las Tecnologías del Lenguaje. My Spanish is yet not perfect. And he will give us this great presentation on challenges for AI in the description of cultural heritage paintings. My name is Carmen McWilliams. I'm the moderator and organizer of this cafe, and I'm the director of Grassroots Arts and partner in the AI for You project. Please take notice that this session will be recorded. No confidential information shall be shared in this cafe session. In this cafe, the speakers express their personal view and opinions. This is not necessarily the official AI for You project opinion. So what is this cafe about? The cafe offers a series of live web sessions which is taking place regularly. The cafe is an online forum to gain insights into the European AI scene. So welcome everybody. Now, welcome Joachim. Hi.
Welcome. Thank you.
And everybody of you participants joining today, welcome. This is an interactive session. Please send us your questions. The speaker makes a presentation. Afterwards, I'm going to read the questions to the speaker. So now I introduce Joachim. It's in Spanish, Joachim, not Joachim. That's German is Joachim, but Joachim Moret. Joachim Moret is working actively in the BSc for the Oficina Técnica de Gestión for the Plan Nacional de Impulso a la Tecnología del Lengua, sponsored by the Spanish Ministerio de Asuntos Económicos y Transformación Digital. He is a senior researcher and expert in computational linguistics. He has a PhD in Knowledge and Information Society at the Open University of Catalonia. His major areas of expertise are machine translation, information extraction, text mining, and natural language processing. So great. It's a pleasure to have you here. Hello again. And I will make you now the moderator. So you get the floor and you can show and you can introduce yourself and even say your organization better.
Okay.
So I make you moderator now. One moment. Yes.
Yes. Can you see the slides now? Yes.
Perfect.
Okay. Perfect. So, well, I am Joaquim Morel Lopez, and I will give you the talk about challenges for AI in the description of cultural heritage paintings. And well, Carmen introduced me, but I introduced myself again, and I put the talk in context. So well, I'm a senior researcher, as Carmen said, but the presentation is based on the work for the European Union project, St. George on a Bike. That it's a project that we work with Europeana. And then the work is also in the context of the Plan Nacional de Impulso a las Tecnologías del Lenguaje, which means, in short, all the activity or we put all the infrastructure in order to boost the computational linguistics and language technologies for Spanish and the languages, the official languages in Spain, and their use in health, in industry and other sectors. And one of them is the one of the cultural heritage, and so yeah, St. George on a Bike is links in this topic, the cultural heritage stuff. And the St. George on a Bike is co-financed by the Connecting Europe facility of the European Union. So I continue. So the contents of the talk are more or less well, these are the contents, the motivation, the pipeline in the description of images, the challenges, which is the topic of this talk, and the next steps we are thinking. So motivation. Well, the motivation of St. George on a Bike project and also the Plan Nacional is how to annotate automatically metadata for images in order for users interact through web pages like Google Images or so, and you can access to cultural heritage in a more attractive way, in a more enriching way, and especially cultural heritage. And we are also concerned with visually impaired citizens because most of the alt metadata, which is associated to images, don't describe the content of the image. It's just a caption that most of the times doesn't describe the content of the image. So for paintings, we thought that it would be interesting for them to know what is depicted in the painting. And sometimes it's just the title, but it doesn't show what the picture is about. So the pipeline in the description of images is more or less this is: first, we have the detection of the objects depicted in the image. So this object detection is performed with a neural network, which the methodology is here you have mask RCNN, which is based on a data set prepared for the cultural heritage domain. Then when we have the objects detected, we see how these objects are related. So this is what we call the visual relations, and we infer the visual relationships between these objects in complete scenes. And then when we have the objects and when we know the relationships between these objects, we generate a textual generation that describes what is going on in the image. So this is the schema of the pipeline. So let's see the challenges. First of all, the main challenge is here you have a photograph of a family at a table eating, and the table is well, you can see dishes, glasses, and so on. This is a photograph, and on the right you see a painting, which is it's quite similar because you can see people sitting at table and there are dishes on the table. But compare the caption generated automatically, the caption that describes the images, and you see the problem we are facing. If you read the caption for the photograph, you see some people are standing by a glass and a woman looks at the wooden dining table. It's quite, there are things that are quite odd, but well, it can be understood. But if you read the caption of the painting, you see that about more with 3 photos on the table. It's quite. This is kind of the caption generated is quite absurd. It's nonsense. And the thing is, well, the images display or depict similar images, but you can see that when the image is a painting, so the caption generation is quite different, and it has more difficulties. So this is one of the main problems we have. Maybe it's for the texture of the image. Maybe it's the disposition of people, that the disposition of people is different in the 17th century and in the 21st century. So these are things that we have to cope with and try to overcome. So, as I said, current approaches are very successful for everyday images, but fail for cultural heritage. It works well with recent pictures because they have been trained with photographs and images that portray present-day life. But what about when we try to describe paintings in the 20th century or 17th century or so? We have a variety of styles. We have, there are imaginary beings. We have witches, devils, angels, which are not depicted and are not represented in photographs. Then we have the question of time that we will see later. And there are also the representation of symbols, pietà, adoration, the adoration of the Magi. And we also have the problem of the data set that, as you may know, when we try to train a system that detects objects with a neural network, we need huge amount of data, and unfortunately, the data available from paintings is not so huge as the data set, the training data set of current image descriptors. So let's see some examples. If we generate the caption that describes the painting on the left, the St. George killing a dragon on a horse, the system says that it's a dog laying on the ground with a dog. So, and if we see the caption for the painting on the right, it says a man on motorcycle and with a helmet on. So this is why the project is called St. George on a Bike, because current systems identify St. George as a person who is riding a bike, and the helmet is not the warrior helmet, but it's the person on the bike and he's with his helmet. So this is one of the examples of how the AI ready for describing present-day images are not quite ready to describe paintings. And even when this painting represents something which is a legend or a symbol or things like that. So let's continue. So well, let's see now, following the pipeline, the challenges in object detection. So as we see here, we have a painting of an angel and a child, but according to the system, if trained with current images, it says that it's a person and another person. And if we see the image on the right, it says that we have a person on the right and then on the left, and the man is holding a cell phone. And of course, the right interpretation should be that instead of a person, we see an angel, and instead of a cell phone, we see a book. That should be the right interpretation or the right identification. So this is this is how the description of person is changed for the description of angel. So here we have the object detection, which is a neural network, which is trained with a pre-trained model, which is a Microsoft Coco dataset. We use this model because it's a model that it exists, and it is used for training image generation systems. So we have this model, and it has it has been trained with millions of images, but then we apply the transfer learning. So we try to implement this model for the image, for the painting. And then we have to take the things into account. One of them is if the object detected is consistent to the time. For instance, as I said, the cell phone. And on the other hand, it has to see if the object to be detected is included in the classes that the system has been learned with the COCO dataset, with the pre-trained model. So there are two actions. One of them is from the pre-trained model, extract classes that are anachronic, that don't fit or are not consistent to the time. For instance, motorcycle, cell phone, etc. And on the other hand, we have to add classes, entities that are not in the pre-trained model, because the pre-trained model is based on photographs, of real image of photographs. So we have to include images of angels and symbols and things like this. So the data set, these are the data set we have used in order to train with new images and so on. And you see that the Microsoft COCO dataset is included. And then, so we have the COCO dataset, we have the classes, and we see that we have to add new classes, and we have to know which are the main classes to be detected in paintings. If we see how many classes are detected in current systems, we see that, for instance, many neural network systems that describe images are based on ImageNet. That ImageNet is a data set of images with 1,000 classes. Then we have the COCO dataset with 300 classes, but we don't know how many classes we have to include when we want to detect paintings. So the thing was, well, how can we get classes that we have to take into account when we describe a painting, and which classes, which COCO dataset classes can be seen in paintings, and which classes are not in the COCO dataset that should be included. So one way to know this was to use the Wikimedia Commons, the API of Wikimedia Commons, and then query the API and ask, well, give me paintings with the category paintings of man, bike, car, stop signal, bus, train, etc., etc. In order to know which of these classes are not likely to be detected in cultural heritage paintings. So by doing this, we got these basic painting classes: people, men, women, humans, trains, boats, birds, cats, and so on. But of course, if we are trying to describe a painting and we see St. George killing the dragon, we cannot say a person on a horse. We would like to be more specific, saying a rider or a knight, or even if you want to be more specific, to say St. George, of course. But people is not quite specific, no? So we wanted to expand these classes to other more specific classes, and then we queried again the Wikimedia by using these basic classes, and we got Wikimedia subcategories. So give me subcategories of paintings of men, and we have paintings of men with animals, paintings of men with books, paintings of men in nature, etc., or paintings of knights, and so on. So what we did is, this is an example, is we give me subcategories for men, painting classes for men, and we have as subcategory paintings of knights and paintings of men with angels. So knight is a more specific class, so the knight is included. And from the subcategory men with angels, men is still in the is already in the COCO dataset, so we just add angels. And then we perform the same thing with the new classes we have added. So if we see subcategories for knights, we see St. George, and St. George is added. And if we look for subcategories for angels, then we have archangels, and archangels is included. And then we iterate until we have, when we didn't have enough subcategories to be taken into account, it stopped the iteration. This is just an example. So by doing this, we have men, knights, angels, St. George, archangels, and Archangel Raphael, and this could be expanded more widely. So the result of doing this is the current classes you have here listed: crucifixion, angel, crown, person, crown of thorns, and so on. And here you have examples of this. So the system has been trained with images of angels. So now it can detect an angel in the painting. It can also detect a boat, banner. Here for the crucifixion, maybe you cannot see the label, but you have a crown of thorns, and the whole painting is labeled with crucifixion. Well, maybe you wonder, what are these squares or the rectangles? Sorry, rectangles here. This is what we call the bounding boxes. Bounding boxes is the area of the painting that is used, that delimits the object, the entity that has been detected. So the thing is that the system detects a figure, and the bounding box delimits the figure, and the goal is to detect this bounding box with the right entity. Here is an example of how the object has not been anachronically detected. So you remember the example, if you saw that you have the woman, well, in this case Virgin Mary, holding a cell phone, but now this cell phone is a book. What is the solution? What has to be done in order to solve this? The thing is that, as I told you before, cell phone is not a class to be detected anymore. So by rejecting cell phone as a class to be detected, then the more probable object is a book. So in that case, because as a cell phone was deleted from the classes to be detected, the more probably object to be held in one hand is a book. For this reason, the anachronism is not here. So What are the challenges when training painting class dictators? So some classes are represented only in a few images, so we don't have so many images as present-day image descriptors have. We have to consider also the style, medium, colors, and all these things. And not so many paintings can be produced, and so we have to work with only what we have. So, thing is, for instance, one of the challenges is imagine that we don't have many images of kings, or we don't have many images of queens or riders. Maybe we have 1,000, but 1,000 is not enough. So, but maybe we have many images of swords. Imagine this. Or we have many images of crowns. And of course, we have many images of people, of person. So one way to overcome the lack of data has been to use a language model. And we use a language model to infer the class without having an image for this class. For instance, if we have images of people, of person, and we have images of crowns, and we can infer the relationship between that person and the crown, which is to wear. And if we know that this person is wearing a crown, we can infer that this person is a king. So we don't have to have thousands and millions of kings and queens in order to detect this class. So in order to infer these classes, we have been using one of the actions you can perform with the language model, which is to predict a missing word. So language model, one of the tasks that the language model is evaluated is there is a gap in a text, and the language model is able to predict this word in this context. So we have used this in order to infer a class that is not in the dataset. So this is the schema for doing this, but maybe it's clearer if I give you an example. So imagine that we have 4 bounding boxes: a bounding box of person, a bounding box of a horse, a bounding box for sword, and a dragon. And then for we see what is the relationship between person and horse linguistically, and what is the physical relation between them. So by using the language model, we can predict that a person rides a horse or is on a horse. So when we have this relationship between them, we perform the task of, well, a person on a horse is a, and then you can see some choices. You have horse. A person on a horse is a horse is not considered because this is a repetition of horse. And then we select the choices that have a meaning relationship. For instance, a relationship of hyponymy or hypernymy. So, for instance, person is in the class, so we don't consider it. But rider has a relationship of hyponymy to person. So for this reason, rider is taken. And this is the reason why among of these examples we take a rider. So we perform this for each of the entities in the bounding boxes. And for instance, a person, the relationship between person and sword is, well, a person carrying a sword or with a sword, and then we predict a person with a sword or carrying a sword is a warrior or soldier. And the same for dragon. So one of the classes predicted that fits the semantic relationship with person, which is rider, is taken, and then person is, so the bounding box that was person is now relabeled as rider, and then we perform the same action. Rider, see the visual, the relationship between rider and horse, rider and sword, rider and dragon, and see if we can infer more specific classes. So in this case, a rider with a sword is you can see a rider with a sword is a knight. So knight is also one of the classes that can be detected or can be predicted if the entity, the relabeled entity, has a specific visual relationship, or sorry, relationship between these other entities in the bounding boxes. So, well, this because a rider and dragon, we can, from the relationships between rider and dragon, we cannot infer other entities. So the prediction is it stops here. So by doing this, imagine that we have an image of a person and a meter. I don't know the pronunciation, the right pronunciation of this. And if we have person, meter, we can infer that this person is a bishop because of there is a linguistic context, which is a person wearing a meter is a bishop. So it's not necessary to have thousands and millions of paintings of bishops. We can infer it by language model. So, well, now challenges in the description of visual content. So far, I have been talking about the detection of entities, and I have also talked about the relationships between these entities. But we have performed a deeper analysis of the entities and their relationships. So we have parameterized images, and we have calculators, the object label, the label identifier, the center point, the object locations. We have taken which is the main topic candidate, which is the entity that is focused on the painting. We have elaborated rules for inference of visual relationships between occurring objects. So it allows for the elucidation of relative positions. And for instance, when two bounding boxes overlap, these rules can say if they are overlapped because one entity is on the other entity, or is with, or things like this. And then we propose a visual relationship, which is the final output. Sorry. So you can see an example of this. From the image, you have the bounding boxes, and the detected object is person one, which is the larger bounding box. At crown, and then we have a person, another person, and the halo. These objects have a reference, and then we can there are these visual relationships. Visual relationship between the person one and the crown, and person one stands, and the person one wears a crown, and person one is covered with a crown. And then, according to the visual relation rules, it can infer that this person is a king or a queen, or it can be a seminary. And for person two, there is a relationship between this person two and person one. Is person one stands, person two is a child, it's an infant or a dwarf, and person one holds person two. So the visual relation of holding is also inferred from the visual relation rules. So, okay, we have talked about visual relations and like stand, on, and these visual relations are cooked in the current data sets. So current data sets like Coco data set or image set or all these sets have these positional relations on, with, so. But what about relations that are not depicted in photographs, like killing? So we cannot expect in Flickr or in Flickr photographs, and which fit current image detectors, we cannot expect to see images of killing people, for instance, and other things. But of course, in paintings, there are many paintings that depict violent things and content which is cannot be depicted in photographs, and it cannot be published in photographs. So what about this? No? So we had to know what kind of visual relationships between objects embodied in verbs can be seen that are not dealt with in current image detectors. So according to this, we thought to process descriptions of painting descriptions from museums and try to get these verbs that refer to actions and relationships depicted in paintings. The problem we had is, for instance, if we take this description, the Martyrdom of St. James from Museo Nacional del Prado, this description has only 3 verbs referring to the action or the relationship between the entities depicted in the painting. For instance, the apostle is shown kneeling with his hands together, offering, and you have the decapitate, and we have wearing. But these are the red squared examples, and we have above them a little angel carries a crown of flowers. So this is a visual relationship between the angel, the crown of flowers, and things. But in green, the green examples are verbs that are not related to what to the content of the painting. These verbs don't refer to any relationship between the entities depicted. So consider, demonstrate, constitute, allude, suggest, they are not. So we had to think of a way of how to detect from collection data set to detect the verbs that refer to visual relationships in the paintings. So one thing we did is we used icon class, and we used the annotations to the classes, to the iconic classes in icon class, in order to see what verbs they use that refer to things that are depicted in a painting. And as we saw some verbs that are like believe or think, we thought that we could select them by using this reasoning, that we would take the verbs whose subject can be a person or a physical object, and the object, the direct object, is a person or a physical object. So like in this case, you see who wears the breeches. So who refers a person, breeches is a physical object, Juno is a person, and girdle is a physical object. Abraham is a person, armor is a physical object. So we took these examples of where. So in that case, we see where. No? So in that case, but it's also for decapitate. So in the case, decapitate, it's in the passive form. So in that case, the subject is a person, but is the passive subject. And of course, in order to identify the entities that are physical objects or person, we used WordNet. We use the hypernym relationships in the WordNet network, but of course the WordNet doesn't contain references to Juno or Abraham. There are very few name entities there, so we had to infer if Homer, Abraham, Juno were persons by using the DBpedia, and by using this we knew if this Juno or whoever was a person. So in order to, for instance, we have some examples of verbs that cannot be visual. For instance, symbolize, maintain, advance, preserve, suppress. But for kill, we have seen that kill appears in the icon class annotations with a person, with a subject who is a person, and an object who is a physical object, for instance. And we have double checked. We have seen if this verb, the kill, which according to the annotation icon class fits these constraints, if this verb is also seen in the title of an image in Europeana, because we assume that this title refers to the content of the painting. So in that case, kill would be one of the verbs we would select as a visual relationship between objects. So now challenges in caption generation. So maybe you know that a neural network that describes an image has as an input an image, then the neural network is trained with this kind of data, an image and descriptions of the image. So they are parallelized. You have the image, and then you have in textual form what the image is describing. But when we try to get, when we want to train the model with captions or with text describing what is depicted in the painting, and we thought about retrieving or getting descriptions of paintings from collections in museums, we saw that most of the descriptions in museums, the information is unstructured, and the real sentences that refer to the content of the painting are embedded in a very large text that refer to other things that are not related to the content of the painting. For instance, from here, the description accompanying this painting has only these sentences that are marked that refer to the content of the painting. All the other sentences refer to the intention of the painter, or biography details, and other information that is not related to the content of the painting. So we face with the problem, and one of the solutions we thought is to implement a classifier like sentence classifier, caption like sentence classifier. So we trained this classifier with the captions that are used for training the neural network, and we have also put Wikipedia articles as examples of text that are not descriptive of an image, and then we train this classifier. And once this classifier was trained, in order to know if a sentence is descriptive or not descriptive of the content of an image, then we tested it with paintings from Web Gallery Art and Europeana, in order to see if the sentences in these collections were properly classified as not descriptive and descriptive. And as you see, the score of this was 0.58, so it was quite low. So we thought that how could we overcome this problem? And we saw that one of the reasons why the classifier was not good enough was this. If the text was, for instance, Christ carrying the cross, since Christ is not an entity which appears in the training of the system, then it says that it's not descriptive. But if we replace Christ with a person, then the classifier says that this sentence is descriptive. And for instance, Christ before Pilate, and then if we replace Christ with Pilate for person, then the sentence is considered descriptive. And if we replace Golgotha for mountain, then the sentence is considered descriptive. So we perform a preprocessing action in the classifier. So if the classifier has to label this sentence, the prophets above with enthroned Virgin, as descriptive or non-descriptive, this sentence is preprocessed and prophets is replaced with people. Enthroned is replaced with an equivalent form, which is on a throne, and Virgin is replaced with person. And then with this version, with this replacement, the classifier says that this sentence is a descriptive sentence. And by doing this, we perform a score of 0.9 when classifying sentences from Europeana collections. And well, now next challenges. Next time challenges is that we want to improve the current methods for tag labeling and description generation, and improving the description classifier, deploy enrichments and implement search and browse functionalities, source more data for training, and we are also involved in the evaluation, notably by crowdsourcing, evaluation of captions, or the caption generated, and experiments. So we are thinking of building a knowledge graph for the domain of expertise, use this knowledge graph and to refine or infer richer objects and relationship labels, and extend the scope of the methods to more general topics beyond figurative and mostly iconographic paintings. And so, thank you very much.
Thank you very much. Also, Joachim, it's very exciting. Directly in the beginning, I want to say if somebody in the audience wants to ask you more questions, can they write you, and where is your email? I mean,
so would you read the questions, you mean?
yes, but my question is, do you want people writing you? Do you have an email?
Or well, if you read, because sorry,
Just because after it's very short now, and is there any way to reach?
my screen now? Yes. Okay. So as you prefer. So if you want to.
Okay. So if you want to write Joachim, you can also send it to me, and I refer to you. Important is Joachim is ready for the questions, and now I'm reading the first question. Apart from helping impaired people, did Saint-Georges on a bike had other objectives when it was born?
Well, the objective is, in a philosophical way, is how artificial intelligence is able to understand the past.
Mm-hmm.
And this was a very huge challenge, because, for instance, now in the COVID situation, mm-hmm. museums have to digitalize their assets in order to show them to the world. And the descriptions of these images, if they have to be made by hand, is very costly and even impossible. So it's a first step. It's the first step to make cultural heritage available for as much people as many people as possible, and we can use artificial intelligence to understand these images, but there is a lack of understanding for these systems when the image is referring to the past. So in a wider environment, is the effort is to contextualize objects, to contextualize them, and and we are working with cultural heritage, but this can be transferred to other kind of images. So we have to understand the context of the relationships and the entities.
Okay, thank you. And next question is, you always refer to this Europeana. Number one, what is it? Number two, will you use your technology for this Europeana data set?
Sorry, can you?
What? I mean, you should explain to the public, what is this Europeana?
What yes, is it? Yeah, Europeana is the well, institution that gathers collections from museums all over Europe, and they provide the platform in order for the general public to access them. It's a platform for preserving European art and the cultural heritage, because there are also images of objects and photographs and all these things. So it's a platform where you can access and get information from all related to European cultural heritage.
And the second part of the question is, will you use your research results and technology, AI-based tools to make the Europeana database bigger?
Yes, of course, because the the goal of the St. George on a Bike is to enrich the paintings, or the images of the paintings in the European collection with this kind of data generated automatically.
Okay.
So there's not only the title of the image or the caption as a reference, but also describing the content of the image,
Okay.
and even the relationship to enrich them.
Now comes a question from one of our participants again. Bruno Sartini, could you please elaborate a little bit more on the content of the knowledge graph that you want to create? Do you already know which ontologies you want to use for the structure of the knowledge graph?
Well, the knowledge graph is a thing that now we are considering. It's an early stage. And of course, we will take the icon class taxonomy, the icon class organization. But also, we want to fill this knowledge graph with inferences from iconography rules, more or less. Mm-hmm. So, as I said before, for the language model, the same for a person wearing a crown is a king. We can infer an angel and a woman sitting, and the angel is on the left. We can infer this is the Annunciation. Mm-hmm. So this kind of inferences we are thinking of implementing this in the knowledge graph.
Okay. So it's already time to stop because it's 3 minutes to 4 and our show is always 1 hour sharp. And last question, can you give me a little bit, it's my question, a little bit, you are in a research group with many people, or you are by yourself in the Barcelona supercomputer? Is this a gigantic research group where you are?
No, well, we are working in a team whose leader is Maria Cristina Marinescu, and we have the neural network developer and the person who is in charge of the visual relationships between the entities, Cedric, and I am the linguist person. So I am the person who is thinking of how to apply language models and things like this. And as I'm more or less a scholar, so I have my literature background and humanities background, I also make suggestions and comments and things like this.
Yes. So I think this was great to get insight in your exciting work. Thank you very much for being here. And
sorry. Yes. But I forgot one person, which is okay. very important person, who is the person who deals with the neural network, who is Artem Rashnikov, who is the person who is in charge of detecting objects and all these things with the neural network.
Okay. So yes, but again, everybody who was today in the cafe, please come back. If you want to be a speaker, please write directly to me. I'm the moderator and organizer of the cafe. Email you have from the invitations. You don't want to have invitations anymore, also drop an email, no problem. And great to see you tomorrow back, I hope. It's the moment we have another one tomorrow, that would be also good. But thank you again and have a nice afternoon, and thank you. Bye-bye, Akim, this was great, and thank you.
If people want to ask me questions, you can provide them my email. And
yes, okay. Okay, then I just connect you further. If you have more questions, I will do it. I just forward them to you.
Okay.
See you.
Thank you very much.
Bye-bye.
Bye-bye.
Bye-bye.